It'd be really nice if we could get hold of a nice little proper signal generator. All right. I wonder what's in this. Let's have a look. The story of test pattern generators can perhaps best be thought of from the view of a TV repairman. So, because back in, I don't know, the 70s or 80s, you couldn't get hold of high quality test pattern generators. So, your TV repairman would either have some sort of homebrew affair or basic simple thing that could do some basic patterns for just setting up a TV for convergence and purity and linearity. But there weren't any sophisticated pattern generators available to a small business in those days. There were complex test pattern generators, but these were very different beasts. The sort of thing the BBC would use. So your TV repairman might end up sort of setting his video recorder to make recordings in the middle of the night on VHS or beta, just so they had access to those higher quality patterns. But of course, they're extremely limited by the tape format itself. So imagine trying to design something a bit like the Philips PM series, PM 5544, 5534. They were full of analog circuitry, extremely complicated and expensive devices to build and use and set up. They cost the price of a small house. A TV repairman could never afford something like that. Now, by the end of the 1980s, those sort of devices were getting a bit old hat. You could do it by more modern technology, and the BBC were quite on the front with this when they had a test card F generator which used memory. So it had EPROMs and 8-bit DACs, high-speed 8-bit DACs, high-speed for the time, which were very expensive. So you have 3 of those for Y, U and V. Now other manufacturers, Tektronix and others, eventually came along with sort of commercial devices, but they were still expensive. They wouldn't of course have used test card F because that was copyrighted to the BBC, but they would come up with sophisticated test card generators, still expensive, out of the reach of the serviceman. And that pretty much stayed the same right until the end of analog transmissions. There wasn't really much of a solution. And if we just look inside, something like Philips ones that use the EPROMs, the PM5644, you can see that a piece of equipment like this doesn't come cheap. They had maybe have started with 8-bit DACs, but improved. 8-bit then became relegated to sort of consumer units, and you'd go up to 10-bit and even more. And that's quite important because some of the features recorded on there needed more bit depth. For example, there's a section which is blacker than black, and we can show that later, and you need more than 8-bit depth for that. So an image of a test card, this is something quite important I want to get across. An image of a test card, say recorded on a DVD, is not a test card. It will be okay for some things, but you won't be able to get access to that blacker than black and also other features that are used for testing the color decoder circuitry, because it's already been decoded on that image. There's a feature where they put in anti-PAL, which is a deliberate phase error on the test card. And it's transmitted that way, and if your PAL decoder is working properly in your receiver, it decodes it, corrects it, and gives you grey. But of course, just an image of grey is not the same as the real PAL decoder test. So let's have a look at what's available today that we can use, which is much more sophisticated than simple test pattern generators that have existed in the past. So this is a system called HackTV, which has been set up by enthusiasts who can use this to generate video signals which are more than just normal video signals. In this case, it's been used for generating test signals, but it could be used not just for 625 line, it could be used for 819 line and 415 and other signals which are extremely difficult to generate on modern equipment. So what do we have? It's not going to look incredibly amazing because it's a prototype that I've been lent. HackTV, I must say I like the box already. That's rather beautiful. Right, so we have video and sync, we have some buttons, extra socket there, audio, power via USB, more connectors there. So we will have to investigate precisely what we can do with this. We'll start by powering it on the computer, and we will be able to talk to this via some software that is available for this unit. Okay, first I'll show you how I get this thing working, and then I'll explain a little bit more of what we have here. Well, it comes with a piece of software called HackTV.exe, but that's a command line thing, which is a bit hard to use. So instead of running that, you run the GUI front end for it, and then you can select what you want. And in this case, we're going to go, well, we have to select, in the output section, we have to tick HackDAC, and I will explain shortly why that is. And then you can select what mode you want, and as well as all these different transmission standards which it will output on an RF output, we're going to select baseband, which will allow us to use the composite video and line audio out. We're going to have PAL because that's what we require, and then you can select a different source. In this case, we're going to select a Philips 4x3 test card, and within the settings we can set text fields if we wish. When you've done that, you select Run HackTV, and on the console output, if everything's working, it will show some information, and we will get the test card on the screen, as we see here. You can have problems. It can sometimes come up with error messages on that panel on the right hand side, including buffer underruns, and I'll explain a little bit more why that happens shortly. But let's assume we get this proper test card. A real test card like this includes sections which will appear the incorrect colour. These greys on the edges will not be grey if the PAL decoder is not working properly. And if you just had an image of this test card, that would not be true. And also, this section here is called PLUGE, and that is negative video. And I can demonstrate that because I've captured some of this, and you can see it with a proper image. And then when I wind the brightness up, you'll see that the black becomes bright, but that is still darker than black, and that's intentional. That means then that when you're setting up a monitor, you can make sure that these blacks are all the same color, that they're both identically black, and then you know that you set the correct black level. If this appears darker than a bit above it, then your brightness level is too high. Now you can only do that if you have negative video capability, which a normal image of a test card can't show you. Right, let me explain a little bit more now about what we actually have, because there's two distinct sections to the equipment we're looking at. Okay, looking at the box here, in the mode we're using it in, it says we have the video output enabled rather than RF, and the RF is effectively a transmitter, and you can set it to all the different transmission standards. This is our USB input. This is one area I'm having a lot of trouble with. It's micro USB. I've got a USB-C to micro adapter here. It's all very flaky. It would be really nice if there was a USB-C socket on the board, but we'll come to that a little bit later. I will switch this off for a moment, or no, let's have a little look at underneath. If I can get the connections to stay stable, here we have a set of buttons and lights. They're not labelled on this prototype, and they're not entirely relevant to what this box is doing, but they indicate, I'll give you a list of what they are. on the screen, but they indicate what's going on with this lower part of the HackTV unit. So what this is two separate components done by different people. At the bottom part we have the HackTV RF unit, which outputs this RF signal, which we're not presently connected to, on this connector, and that will produce all the different television system output signals here at a fairly high output level, sufficiently high that it can act effectively as a transmitter. And I've just lost connection with that, so I'll unplug it for a moment. On the top section here we have the part which required us to select that DAC feature, HackDAC, because what's going on there is that the unit underneath that was originally designed to output a television transmission signal, an RF signal here, has an extra PCB fitted to the top, which is allowing us to take out stereo audio and composite video. But it's not any old stereo audio and composite video. It's extremely high quality, using very high performance DACs that are installed on the top PCB, and that has been done by Matthew of Matt's TV Barn, who has kindly lent me this unit, and he's done the top PCB here that's giving us this extremely high quality composite video output. Now I think Matt knew I was going to say, so he preempted it, and you're going to say, so I'll preempt it, why only composite output? Why not S-video? It's actually quite complex to add S-video to this, though it's not impossible, and it is something that could happen in the future. So perhaps this one day will have composite video, will have S-video output for recording onto, say, SVHS. Now, some of these bits and pieces feel a little bit unfinished in the HackTV software. There are some bugs in it. For example, I found that you can save a template or save your configuration file, and you should be able to load it back up, and when you load it back up it didn't work. There are some interesting templates in it. I like this. There's Astra analog set-top box. Do you remember the original Sky transmissions? For example, do you remember in the early days of Sky Television, they broadcast UK Gold, and it was using a transponder on the satellite that wasn't really intended for transmission to the UK, and so the signal was very weak. And if you had a small dish connected to your cheap and cheerful little Amstrad set-top box, it was covered in sparklies and darklies all the time. It was a UK Gold signal. It was intended for UK reception, but it didn't work in the UK, especially when it rained. And the other one I particularly like there is BSB DMAC set-top box. Oh yes, square eels. I've done a short website about square eels and the square dishes and all that, and I've actually got some example ones which I will show you. Actually, I dug them out of the garage the other day, so we can have a little play with those. So it has some fantastic possibilities. What I've been given permission to do is take the lid off this, and we can have a quick look inside at the two distinct parts to this unit. So the lower part here is the original HackTV RF box, which has some lovely RF electronics in here, which gives you a RF output, effectively a transmitter. These are further connectors. I will give you information on what those connectors do. On the top part here is the HackDAC. This one's alpha version 2. And it's giving us the really high quality composite video output and also a sync output there. And one of the benefits of the sync output is that if you're using one of the sound in sync modes, it can be difficult to, for example, trigger an oscilloscope on that. So having a sync output can be useful rather than just trying to use the composite video. That plugs in through these connectors along the edges here onto the ports that were already available, fortunately, on the HackTV RF component. So that explains a little bit about why this feels like it's two separate things. That's because it is. So this lower board that's been done by the HackTV group, I'll provide some information on screen about them. They may or may not create a version with a USB-C port at some point, and it would be advantageous if they can, but not as trivial as it may sound, because one of the things they might need to do as part of that upgrade is to improve the speed of the USB devices on the input here, because remember I mentioned that you can get buffer underruns. That's because the data rate that this is providing for constructing of that television signal is right at the edge of what USB 2 can reliably provide, and depending on your particular computer you may not get it to work reliably every time. So a USB-C upgrade would almost certainly involve also upgrading some of the electronics on the board. So it's a little bit non-trivial, but I think that would be an extremely useful upgrade. Now this HackDAC board, as you can see, is a little bit non-trivial to build. There's a lot of alignment required to get this exactly right, and at the moment it's just Matt building these, and he would get swamped if there were large requirements, large orders for these boards, because these have to be set up using specialized equipment. So at the moment this is still very much in the prototype stage. Let's carefully reassemble that. I've been playing about with this a little bit, having a look at the RF output. Now I know that the main feature of our work today has been looking at the DAC option on the top for giving us the composite video and stereo audio, but let's have a look at the RF output. Now I'm not sure what the settings are in terms of power output, and I don't want to give my TV so much signal as to blow it up, but I have had a little bit of a play with getting our output of a test card on channel 23, which is what the TV is tuned into at the moment. One thing I did notice though is when I power up the box, I do see a certain amount of noise on the TV. Let's see if we can see that now. I don't know if you can see it, but there's a certain amount of noise, so I think this radiates noise on across the band, the UHF band, which is a little bit untidy, but okay. Now initially I had set, there's a parameter here of TX gain, and initially I set that to 0 and ran it and got a very noisy picture, very low gain. I messed about with the gain and I've put in a value of about 45 dB there and run that, and I get a nice clean signal. I was concerned I was going to get too much RF output, and that might have happened if I'd selected the TX RF amplifier. If I do that, it warns me that I could damage things. So I decided against using that. It might be that you need to get the impedance matching correct on the RF output. What I was going to do to try to attenuate that signal and keep it safe and legal, I grabbed myself a baked bean tin and I was going to drill a hole in the bottom and make this act as a Faraday cage, so have a small RF antenna out of this and one into the TV. But in the event I don't need to, because there's good control of the amount of gain I get, so long as I don't select the TXRF amplifier mode. So I'm quite happy that with a 45 dB setting, I'm getting what looks to be about the right signal for the TV. I would say, and you'll never see it, but there is in the background a small amount of like dot crawl, it's noise. So it's not like it's putting out the world's most beautiful signal, but it's pretty good. And I could use that with a suitable adapter from this connector to plug into something like a N1700, which doesn't by default have any audio and video inputs. So I could make up N1700 test tapes using the RF output. So as well as the composite video and stereo outputs, which you could connect directly to more modern video recorders, you could use this for generating signals for testing TVs and certain video recorders. It's very useful, this thing. The test patterns here, the Philips ones, have been provided by Carsten Hansen, who really needs to be thanked because he finished up with all the rights for the IP for the hardware and software for the Philips test pattern generation, and he's made it all open source, which is a wonderful thing for everybody involved in this sort of thing. Now there are sort of several layers here. What Matt's done is working on the DAC side of it to allow us to have these video output connectors, but it all sits on top of the HackTV project, which was never originally specifically designed for these test signals. That's something that's been added relatively recently. That is also very useful for generating video signals, moving audio and video signals for all kinds of TV and video and satellite equipment. And then all of that sits on a software-defined radio platform. So there are multiple sort of layers to this. Right, okay, I will have to hand this back to Matt. It's a prototype, so I will hopefully get hold of one of these finished ones later on. Right, I hope you've enjoyed what we've done here. I'll do plenty more content on audio and video technology in the near future. Bye for now. Matt tells me that he does have some more of these boards completed already, so if you want to buy one, I'll provide his details. Now, he doesn't have a finished design yet for the box for what it's sitting in. So, a little bit later that'll come along. And also, he only has a certain amount of those boards available. So if there's a large demand, he'll have to get some more made, which will be time consuming because, of course, they do take quite a while to configure as well. Okay, so all those details will be provided in the notes below. This morning I've had a spot of bother. This is on channel 23. I can stop and start the HackTV, but I'm not getting any meaningful output. And everything's set up as it was before with the normal test cards and things. So I'll use the composite video connection and start HackTV in the right mode for having composite video, because it doesn't do both at the same time. And on the composite I'm getting nothing, just a certain amount of something because the TV's starting to flicker. You see that the on-screen graphic is flickering there. So some sort of sync pulse is arriving, and if I stop it then that effect goes away. So it would appear that at the moment this unit is not outputting from the composite video or the RF output. Have I done something wrong? That was clearly something and nothing, because I've set it up here on a different computer, plugged into Beta Hi-Fi, and it's working just fine. So
Maybe that was a bit of computer trouble.